What is a relation? Well, in order to understand a relation, one must know about the Cartesian product of sets. So what is the Cartesian product of sets? Well, if we have two non-empty sets, say A and B, then the set of all ordered pairs A, B such that A belong to A and B belongs to B is known as the Cartesian product of the sets A and B and is denoted by A cross B. Now consider an example in which set A has elements 1, 2 and 3 while as set B has elements X and Y. In arrow diagram one can easily observe that an element 1 of set A can be related to the elements of set B in two different ways as 1, X and 1, Y. This observation extends to the other elements of set A as well. Thus A cross B can be written in roster form as 1, X, 1, Y, 2, X, 2, Y, 3, X and 3, Y. Therefore we can say that the total number of elements in A cross B is equal to 2 into 2 into 2, that is 3 times 2, which is equal to 6. Thus in general we can say that the total number of elements in A cross B is equal to the product of total number of elements in set A and total number of elements in set B, that is n of A cross B is equal to n of A and to n of B. Thus, one can say that a relation is any subset of A cross B. In set theory, we know that if any set say A has n distinct elements, then the total number of subsets of set A is equal to 2 raised to the power n. Similarly, if the number of elements in set A and B are n and m respectively, that is n of A is equal to n and n of B is equal to m. Then, the total number of ordered pair elements in A cross B is equal to n into m, and the total number of subsets of A cross B is equal to 2 raised to the power nm. As each of these subsets of A cross B defines a relation from A to B, the total number of relations from A to B in this case would be 2 raised to the power nm. Of which the void relation, OI, and the universal relation A cross B are known as trivial relations, that is, being mathematically simplest case. The universal relation A cross B is also known as improper relation. Some important points to be remembered. First, the total number of subsets or relations of A cross B is equal to 2 raised to the power nm, where n and m are the order/cardinal number of A and B respectively. Second, the total number of trivial relations from A to B is equal to 2, that is void relation, OI, and the universal relation A cross B. Third, the total number of improper relation from A to B is equal to 1, that is the universal relation A cross B. Now let's discuss about the domain, range and codomain of a relation. Let R be a relation from set A to set B, then the set of all the first entries of the ordered pairs belonging to R is called the domain of R, and the set consisting of all the second entries of the ordered pairs in R is known as the range of R. The set B in this case is known as the codomain of R. Clearly, range is a subset of codomain. Thus, domain of R is a set of all elements A such that A, B belongs to R, and range of R is a set of all elements B such that A, B belongs to R. For example, let set A contains elements 2, 4, 6, 8 and set B contains elements 1, 3, 5, 7, and let R be a relation from set A to be given by R is equal to 2, 3, 4, 5, 6, 7. Then, domain of R is equal to 2, 4, 6 and range of R is equal to 3, 5, 7, and codomain of R is the set B which contains elements 1, 3, 5, 7. As we conclude the first part on relations and functions, let's delve into the concept of inverse relation. Inverse relation. If we consider the statement Umar is the husband of Insha, the relation referred to is the husband of. One can write the statement as Insha is the wife of Umar. The relation in this case is the inverse relation of the relation stated earlier. Thus, if A and B be two non-empty sets and R be a relation from the set A to the set B, then the inverse of R denoted by R raised power -1 is a relation from B to A and is defined by a set containing ordered pair element B, A such that A, B belongs to R. Obviously, A, B belongs to R double implies B, A belongs to R inverse. Thus by the definition of R inverse it's clear that domain of R is equal to range of R inverse and range of R is equal to domain of R inverse. In the second part we will discuss relation on set A and explore various types of relations. Thank you for tuning in. We hope you enjoyed the first part. Don't miss out on the second part, it's going to be even more exciting. If you found this video informative, then don't forget to like, comment, share and subscribe. See you in the next part.